we can always rescale a vector to a unit vector. How? Let us have a vector like vector v. Let v be vector with components x1, y1, and z1. By dividing vector v by its own magnitude, you create a unit vector. U, or this new vector with length 1, can be constructed using this vector with any length. We take the magnitude of vector v and we divide each of the components by that magnitude. So your new vector has first component x1 divided by the magnitude of v, comma y1 divided by the magnitude of v, and z1 divided by the magnitude of v. Vector u has magnitude equal to 1. So it's very important. In many cases, especially in linear algebra, you're dealing with vectors with large magnitudes. You're interested in rescaling those vectors into a nicer vectors with a length 1. One method is rescaling them by dividing the components of the vector by its own magnitude. Let's go over one example to feel more comfortable about rescaling a vector. Example. Let us have a vector 2, minus 1, and negative 2. This is our vector. Question says, find the unit vector in the direction of this vector. Find a unit vector in the direction of the given vector. So the key word here is unit vector. You're interested in finding this vector u. So suppose v is our vector here, 2, minus 1, and negative 2. What do we need? We need to find the magnitude of this vector, which is 4 plus 1 plus 4, or square root of 9, which is 3. Now, we divide each of the components of this old vector by its own magnitude, and we call it vector u, because it's a new vector. Vector v divided by the magnitude of vector v. So here we have 2 over 3, negative 1 over 3, and negative 2 divided by 3. So in a sense, we are doing a scalar multiplication. What is that scalar? That scalar is a third. A third times 2, negative 1, and negative 2. Indeed, this vector has magnitude, length, or size equals to 1.